Welcome to Notes of Pharmacy. Today our topic was high performance liquid chromatography. In this topic we are discussing about introduction, theory and principle, instrumentation, advantages, disadvantages and applications. Coming to the introduction. High performance liquid chromatography is also known as high pressure liquid chromatography or high precision liquid chromatography. HPLC is a liquid chromatographic technique in which separation of the components from a mixture is achieved by pumping mobile phase at high pressure through a column. High performance is the name indicates that HPLC offers improved performance than other conventional column chromatographic techniques. This is because it utilizes a stationary phase which has very small particle size, so provide a greater surface area. Then coming to the types of HPLC. Based on mode of chromatography and based on principle of separation. Based on mode of chromatography, there is a normal phase HPLC. It is a type of partition chromatography where stationary phase is polar and mobile phase is non-polar. Then based on principle of separation, adsorption chromatography, ion exchange chromatography, gel permeation or size exclusion chromatography, affinity chromatography and chiral phase chromatography. Adsorption chromatography. In this separation depends upon the relative affinities of solute molecules towards the stationary phase. In ion exchange chromatography, the principle involved in separation is reversible exchange of ions between the ion exchange present on solid support and ion solute molecules. In gel permeation, the principle involved in separation is the difference in size and shapes of solute molecules. There are different types of gels are used which acts as sieve for separation. In affinity chromatography, separation of components from mixture depends upon the affinity of solute molecules towards the stationary phase. In chiral phase chromatography, this technique is used for separation of optical isomers using chiral stationary phase. Coming to the principle and theory. Principle of separation is based on the normal phase mode and reverse phase mode is adsorption. In theory, retention volume and asymmetric factor. In retention volume, the volume of mobile phase required for elution of 50% of a compound from column is called retention volume. Formula has VR is equals to RT into flow rate. In asymmetric factor, theoretical peaks should be symmetrical. However, symmetrical peaks are not obtained due to fronting or tiling. In fronting is term used when left side broader than right side. This is why because reason sample applied in large quantity. In tiling is term used when right side peak is broader than left side. This is why because reason is great absorption of sample onto a stationary phase. Coming to the calculation of asymmetric factor. Asymmetric factor is equals to B by A, where A and B is distance of sides from line of symmetry. It should be between 0.95 to 1.05. Coming to the instrumentation. HPLC consists of pump, mixing unit, solvent degassing, injector, column, detector and recorder. Coming to the first one, pump. The role of pump is to force a liquid, that is mobile phase, through the column at a specific flow rate expressed in ml per minute or centimeter cube per minute. Normal flow rate in HPLC is 1 to 10 ml per minute for analysis and up to 30 ml per minute for prepared analysis. They should generate high pressure up to 6000 pressure. During the experiment, a pump can deliver a constant mobile phase composition that is isocratic and an increasing mobile phase composition that is gradient. Gradient is the best for analysis of complex sample. Mainly three types of pumps are used in HPLC. First one, constant flow reciprocating pump, and then second one, syringe or displacement type pump. In this consists of large syringe like chamber and that is suitable for small bore column. Third one is pneumatic pump. In this, gas is used to pressurize the mobile phase that is present in a collapsible solvent container. Then mixing unit. Mixing unit is used to mix solvents in different proportions and pass to the column. Mixing of solvent is done either with a static mixture which is packed with beads, a dynamic mixture which uses magnetic stirrer. Then solvent degassing. Several gases are soluble in Organic solvents. When solvent pumped under high pressure, gas bubbles are formed, which interfere with separation process, steady baseline, and shape of peak. So, degassing is necessary. Degassing can be done by three filtrations like vacuum filtration, helium purging, ultrasonification. In vacuum filtration, it removes air bubbles, not always reliable and complete. Helium purging. By passing helium through solvent, very effective but expensive. In ultrasonification, by using ultrasonicator causes mechanical vibration, remove air bubbles. In injector, the injector serves to introduce the liquid sample into the flow stream of mobile phase. Typically, sample volumes are 5 to 20 ml. In sophisticated HPLC system, an auto sampler provided with microprocessor. Actually, three kinds of sample injectors are mostly used in HPLC. Syringe injector or septum injector. Second one, stop flow injector, and then rheodyne injector or loop injector. First one, syringe injector. In this syringe injectors with self-sealing elastomer septum is used. The material used for constructing these injectors should be able to tolerate pressure as high as 1500 pressure. In stop flow injector, flow of mobile phase is stopped for a while and the sample injected through a valve device. In third, loop injector, it is the most popular and automated system for injecting small amount of sample. This has a fixed volume loop like 20 ml or 50 ml or more. Injector has actually two modes. Load position where sample is loaded into the loop. Inject mode, the sample is injected into the column. Coming to the column. Analytical column is central compartment or heart of HPLC instrument where actual separation of components cross. So, proper selection of column is necessary as it affects resolution, peak symmetry and speed of analysis. For analytical separation and also for preparative separation. Coming to the analytical separation, column of length 25 to 100 cm with 2 to 6 mm diameter is selected. For preparative separation, columns of length 25 to 100 cm with internal diameter of 6 mm or more is used. Columns are made up of stainless steel, heavy glass, polyethylene or polyethylene ether ketone are used. Stainless steel columns are preferred as they can withstand with high pressures. Types of columns: conventional column and microbore column. In conventional column, operating pressure is 500 to 3000 pressure, which is less efficient. In microbore column, operating pressure is 1000 to 5000 pressure, which is more efficient. Coming to the detectors. The main function of detector in HPLC is to monitor the column effluent and also detect the amount of sample present in it. Detectors used in HPLC are UV visible detector, refractive index detector, fluorimetric detector, conductivity detector, amperometric detector. Coming to the advantages. It offers high separation efficiency and speed of analysis. It offers high degree of selectivity due to wide variety of solvents and column packing. It requires less amount of sample and allows continuous monitoring of column effluent. As it can operate with wide choice of mobile phase and stationary phase, it can be used in analysis of polar and ionic substances, metabolic products, thermoliable and non-volatile substances. The result obtained are precise, accurate and reproducible. Coming to the disadvantages. Maintenance cost of equipment is high. HPLC columns are expensive. Pre-treatment for solvents like degassing and filtration are required. Skilled and well-trained personnel are required. Large amount of solvent, that is mobile phase, is required for separation. Due to closed system, visual detection of components is not possible. Coming to the applications of HPLC, it is used for both qualitative and quantitative analysis. It is used in inorganic chemistry for separating anions and cations. It is used in environmental studies, which is pesticide content in water. It is used in food analysis, like separate water and fat-soluble vitamins in quantities of antioxidants and preservatives in food. It is used in forensic science and also detection of poisons, alcohols, heavy metals, etc. It is also used in orgochemical industries. and also various components of plant products like analysis of cinchona digitalis, ergot, etc. And it also used in separate coal and oil products for crude source, and it is used in nucleic acid research. Thanks for watching. For more information, please like, share and subscribe to our channel Notes of Pharmacy.